Good morning, everyone, and welcome to Physical Science 110. Today is actually Monday. Thank you, Alexis. Today is Monday, August 23rd. This is our second live meeting, basically live session. We're going to hold in here. I know some of you are joining. The recording is going to be posted later on Canvas with probably a couple of items of discussion in here. As a general rule, please pay attention, okay? So you really need to grab a piece of paper and a pen as much as you can right now with you guys. And if need be, also a calculator, because in the examples I did from the, I'm going to talk about that, okay? They require a little bit of following. You really need to follow that, which brings me to basically how the mechanism works in this class and things of this nature so that we are all on the same page. Again, before I start, I really must make an emphasis on the project that is due this week, okay? It's not a project, discussion item. One of them is due this Thursday. Actually, you need to do both parts. One of them that is due Thursday and the other one that is due Saturday. I know a lot of you submitted, but a lot of other people also did not submit. So it's very, very critical that everybody does this assignment for two reasons. First of all, it's worth a lot of points. 20 points total. The first part is 10 points. The second part is another 10 points. We really need to earn those points in here and do them to the best of your abilities, okay? This is not a challenge. This is something that is well within reach. All you have to do is dedicate time to them and take care of them. And it should not be hard. I mean, everything should be straightforward. If you have difficulty or if you have issues with the camera or something, please let me know. And it should not be an issue. Just, it's better to get some points rather than nothing. It is a must that they have to be done by these due dates. For two reasons, in addition to the fact that they are graded. The second reason, which is actually crucial, and could have tremendous implications, and that is you may be dropped out by the census date, which is sometime next week, okay? So in other words, you really have to take care of that. There is no way for me to take attendance. If we are on campus and we do the attendance, then we can submit the attendance to the college and the college can take care of things. If not, this is my way of doing it to make sure that you're participating and doing what you're supposed to be doing in this class. Once you complete this task, at least you are going to make it to the census date. If you do not complete this task, in addition not to completing other things also, like the first questions that came from last week, then in this case, I assume that you just enrolled. And I know for those who are not watching, this is irrelevant for them. But for those who are watching so that they don't fall into that trap in here, whether you're attending live, and there are quite a few of you, or those who are not attending live, namely watching the recording, you must complete these tasks. The fact that you're attending live or watching the video is not going to help in a sense. What it really does is completing those things. So you must do that flat earth. Let me share with you the screen to show you what I'm talking about to make sure we are all on the same page. This is what I'm talking about, this assignment, okay? It shows in here it's due the 28th, and that, as I mentioned before, it has two parts. The second part is due the 28th, and Canvas picks up the second part. So it's due really the first part on this Thursday. So this is going to determine whether or not you're going to be basically retained in the classroom. So I'm going to report that the student is not participating based on this one. In addition, I will use this one also as a reference. This one probably is not going to work because it's still probably due after that, and we will not have a chance to look at it until after the census date. So those two are very, very important. By far, this is the most important one in terms of its own weight. Also, it weighs 20 points. So it's very important to do this one. In addition to the fact I'm going to use it as an attendance also for the class. to the college for the census date. Is this clear? Does everybody understand how important this one is, at least for those who are here?
Yes.
Okay, very good. Thank you. So we really have to take care of it. I know a lot of you did submit it, but there are quite a few who did not. So I really want to make sure that the people who are watching the recording or live to understand that this is important for other purposes, not just the grade. So that is one thing I wanted to emphasize on up to this point. You notice something pop up in here that you didn't see before in the past, and that is the week 1 review. I couldn't do week 0 review because we didn't have that week. So every week you will have something similar to this fashion where I go briefly through the lecture. If you click on it, I'm going to click on it. I'm a student anyway right now. Okay. And I'm going to play the video. It's going to summarize the concept, but then it has applications, it has problems in it. Okay. I will do this regardless of whether or not we have an assignment or not. What I want you to do is the following. Once you see these recordings, first of all, you're supposed to do it anyway for all of the classes, including the live session that we have in here. And that is to grab a piece of paper and a pencil or a pen and start following. This is not a spectator sport. And I know you heard it from other instructors, but this is probably more so in this class than anywhere else. You really have to do, you cannot watch me do things. You have to pick up a piece of paper. You have to grab the book also. It's a must that you have to have it. If you don't have it, most of the times, at least in the beginning, I will tell you what the problem is, and you should not have difficulty following, okay? Down the road, if there is an assignment, and there will be some assignments scattered throughout the semester based on this thing, you're supposed to have the book. If not, let me know, and I will post a copy or try to take a picture of the problem from the book and post it for you guys. So there should be, you should have plenty of things. You need the book anyway for reading. You really have to read these chapters, because if you can't read them, or if you don't read them, I should say, you're going to have difficulty with your exams, because that is really the bulk of the material where it is. It's through the reading. And then you can come in here later on and see this review. It's my take on it, my summary over it, so that you guys can see basically some of the things that we're doing in here. So that should be helping you. It's not in lieu of, it's not a replacement of your reading. You read, if you don't understand, please let me know, and we should not have a problem discussing that specific item. And then I will try to go and explain things. And today I'm going to actually go with the second unit and explain it, but I'm not going to be doing problems from the second session. As a matter of fact, what I will be doing is actually the problems we'll be doing part of the review next week based on this week. So week 3, you will see week 2 and it's part of the review and so on and so forth. So you are supposed to go through this one in here. I must tell you the comments that you post in here are not attended. So if you have questions specifically about these items, please send me an email via the inbox. Send me a message via the inbox to know, and try to be very specific. Try to tell me this problem from this specific one in here. In addition to the fact, if you're sending me an email, you really have to, outside of this form in here, you have to tell me what your class is, because I have so many classes, it's not even funny. So you have to really tell me which class you are in so that I can help with that. So this is the week 1 review. Again, expect this from this point on to see an item like this one for the week before. I will go and record the summary of the lesson, basically going through the same PowerPoints that we discussed, and then pick up a couple of problems or more to have some applications in here. There will be another item that pop up from time to time, not all the time, homework assignments in here, which brings me to item 1 of the discussion today. Okay. Namely, how we're going to solve this problem. I already alluded to that when I talked about this one in here. So when I'm doing the examples, I expect you guys to understand those examples. In other words, you pick up a piece of paper and a pen, and you start doing the same thing step by step. If you have difficulty or question, ask. Do not assume that somehow it's going to become clearer down the road. It won't. Actually, it's going to be more complicated. It's going to be harder. So ask right then and there. Send me a message. I tried to follow the example. For some reason, I'm not getting the same number, or I didn't understand how you did that step, and so on and so forth, okay? Because people come to this class with different varying levels, and this is the textbook that was adopted by the college, and it has these examples in there. And the examples are very, very useful to help you basically retain the concepts. It's usually the numbers that tell you the story. That's why we do numbers, because they really speak louder than anything else about the concepts. So that's why we do that. These experiments, these concepts, they will fade out. I mean, probably 6 months from now, probably you will not remember things unless you do things. Then you will retain a lot of them. And I will tell you what concepts to watch for, what are the key concepts, but it will not help unless you actually are engaged in the classroom and doing things. So it is very important that you do that. Now, let's say we have an assignment, and there will be some throughout the semester, homework assignments. I will tell you the page number, and I will tell you the problems that you're supposed to be working out. This is the item of the discussion today, at least one of the items of the discussion today. The first thing I want you to do is try to work in teams. If we were live in the classroom, if we're meeting in the classroom, I will force you to be in a team, working with other people, okay? This is a skill. Working with teams is actually a skill, and you really have to take it from this classes. Physics, especially physical science in general, is a collaborative endeavor. People work together. Not a single person can do everything by him or herself. You have to be in a team to do things. So you need to work in teams in doing these problems. This is not supposed to be an exam. This is not supposed to be a challenge. This is supposed to be a tool for you to learn the concepts. There is no harm in working with another person or other people. As a matter of fact, you're encouraged to do so. There is no harm in researching the topic. As a matter of fact, you're encouraged to do so. Understanding what you're writing is very critical. There is no harm in asking me a question before, during, or after. As a matter of fact, you're encouraged to do so, okay? That shows a level of engagement and commitment to the classroom, and for your commitment to really progress in these concepts. So that is what you are supposed to be doing. So again, when we're given problems like this one, it is recommended, because we're on an online environment, to work in teams, whether virtual or in person, provided you observe all the health and the safety guidelines, okay? Now, during that time, you're supposed to do research on the topic before, during, and after. You can reach me on these things. Does everybody understand what the prompt is and what the answer to it is? Yes, no? Maybe?
Can you repeat it again?
Okay. Throughout the semester, there will be several homework stops where you're supposed to do problems similar to the ones that I did in week 1. There were 4 problems from previous chapter. I worked them, okay? You are supposed to work in teams, okay? You are not required, but you are encouraged to work in teams. You have to pull your own weight in the team, making sure that you do your own part in the team, researching the topic, reaching out for help at any level, at any point in the process. Because the point is, you understand the concept, and it's not an exam, it's a homework. Make sense now?
Yes.
Okay, very good. Thank you, Stephanie. Everybody else. Okay, very good, Samantha. Okay, so we're on board in terms of this assignment. So however you put it in your own words. So this is item 1 of the discussion today. However you put it in your own words. If you don't agree with somebody else's approach who thinks that this is not supposed to be a collaborative endeavor and you're supposed to work on your own, then you can basically disagree with them and show them why this is important, because this is science. This is a skill that you can take from this class to your workplace. You can take this skill from class to workplace people, because in workplace people work together also, and that is what is expected from you to do things. You're not supposed to do everything by yourself. You're just part of the whole picture, big team, even if you are the boss. Okay? As a matter of fact, most of the time, bosses don't do anything. Okay, they just watch people do things. Okay, so, but without them, things don't get done. So they can, if they leave, go home, everybody goes home with them too. So anyway, so let me go back to see where we stand. So we've cleared this point. So as promised, every week you will have an item like this one. Sometimes you will have homework assignment where you're going to follow the steps, basically working together in teams and answering them and submitting them. There will be actually a grading schema in them, and they will be for a grade, and there will be deadlines on them. There will be due dates on them. So you have to observe that. That's part of your overall progress in the class. So this is the type of things that we're expecting to do in this classroom. Read the materials. This is just an outline. This is not the whole material you're supposed to be reading. You're supposed to be reading the actual book, okay? And then after you do that, you do the examples, you do the activities related to it, and the activities are broken down into two things. A weekly thing that is going to be from now on is going to be this discussion items, okay? You have seen already one from last week. Every week there will be one, okay? Item one of the discussion today has to do with how to handle problems. There could be more items today, okay? Item one from last week, or a single item from last week, has to do with how to handle this overall discussion points, okay? And then there will be also another item in here that pops up in here. After you read these things, you're going to come in here and see the terminology that was covered from the previous week. This is, if you wish, a written summary of what was covered last week. So again, at this point, you're accountable for the previous week. If we test right now and I give you a quiz or an exam, week one should be completely 100% covered. So we don't have any excuse whatsoever for it, okay? So at this point, we have everything. We've read the materials, we saw the outline, we had a discussion. I already reviewed the discussion. We had examples from it. Furthermore, we have a written summary of all the examples from that. Now we're ready to do this week. And here is the outline for it. We're supposed to read the materials again and get ready for what is going to come next, okay? So we know we have a skeleton right now for everything and how it's structured. I don't, there is a question in here, and it's really a personal, private question, but I don't think it's really, it can be private anymore, because the question can be actually answered public. I don't have live classes. These classes are all online. Okay? At this point, I'm supposed to go either tomorrow or the day after to campus to see if I can get my keys for the office, because at this point, I really don't even have an office. Does that answer your question? Okay, no problem. So we're still doing online classes, okay? And we'll have only online classes this time. And we'll be meeting in the office once I get my keys on campus. Otherwise, we'll be meeting also virtual. I mean, we can still meet virtual even if I get my keys. Okay? So this is everybody's benefit, not just the person who asked the question. Okay? So, so this is basically like a skeleton for what is going to come next. There will be an item or two depending on the assignments that you have for that week. But this is in summary basically what to look for throughout the semester for this class, which is in here, okay? as I was saying, and I know quite a few of you were not in the beginning with us in here, this is an important assignment, okay? This is a very, very important assignment that is going to determine whether or not you're going to be stayed enrolled in the class or not, because I'm going to base your attendance based on this assignment. Doesn't matter how much you score in it, even if you get 0 in it, okay? As long as you submit it, okay? You never get 0 if you submit it, okay? There is always credit for work here and there, okay? Same thing for this one. But I'll go off of this one, because this one, for example, has a due date that will not be examined until after the census date. So for those who came in late, this is a very important assignment that I really need you to submit it on time before its effects, in addition to the fact that it's worth 20 points, okay? That's still an important fact too, okay? So this is basically the stuff that I wanted to talk to you guys in terms of general ideas, and also in terms of the first item of the discussion today. So let me share with you, let me first of all pull it, let me stop sharing the screen, and let me share with you the items from this week. Okay. Let me tell you from the get-go, this is probably one of the most important days in your lives. Okay. I don't know where you were when Kennedy was assassinated or any other important date in politics. Probably you were not even born. Okay. For sure, you were, for the most part, probably you were not born. Okay. At that time. Anyway, this is the date when you discover the 3 laws of Newton. This is the date that you discover all you need to know to solve any kind of problem in physics, okay? These are the laws of Newton. There are 3 of them. First law, second law, and the third law, okay? It's all you need. You don't need any other law in the universe, okay? To help you do any problem and understand any problem and do any kind of problem, try to understand it, go to understand, for example, how the stars functions, understand how the car works, understand, for example, anything, if you know these 3 laws. Isn't this amazing that we finished this successfully? We don't need anything else. Yes, no? That's a tall claim, isn't it? Okay. At least one of you agree too. Okay. It is really the truth. Okay. This is not an exaggeration whatsoever. I mean, some of you are then wondering, why are we meeting next week? If we understand these things, then we understand everything. So what? Then the class is over then, isn't it? Isn't that a legitimate question? Yes, no? Okay, so 2 things. First of all, this is all you need. Second question, okay, how can we justify coming next week and finishing this class? Because I'm telling you, everything you need is in these 3 laws, okay? Everything you need to understand that everything else in the universe is really these 3 laws of Newton. The first law, the second law, and the third law, okay? And if anything at all that you will remember from this class, 6 months from now, a year from now, 5 years from now, is the second law of Newton. As a matter of fact, if you ask any physicist a question to solve for you, most of the time they start with the second law. Okay? Most of the time that's what they do. Engineers, they have other tricks though. If you ask an engineer to solve a technical problem for you or try to find a solution for an engineering issue or something, they have shortcuts and they have other ways of doing it and they are more effective. but we basically start usually from this point in here, okay, which gives us a very long way of doing things, and most of the time it becomes too hard, and we have to do other ways also once we reach the point where we actually have to get the help of engineers to apply these things. Okay. Anyway, the point in here, the second part here, how to proceed. How do we proceed from this point? Okay, we need to have a plan of action. Otherwise, basically what I'm telling you is we're done. We should be done, okay? So the first thing in here, these are the laws that govern everything. And let me from the get-go tell you what these three laws are, okay? Because that is the second item of the discussion today, is to state the three laws of Newton. So we're going to say law number one is what I'm going to tell you. Law number two is what I'm going to tell you. And law number three is, and you're going to say what it is, okay? First of all, what in the world is a law? What is a law in physics, okay? Because we're using this term in here saying it's a law, and it's a law. So what is law, okay? It's kind of a rule, but this is something that happened time and time again. You cannot violate a law in physics. Laws are something you observe it yesterday, the day before, today, and repeatedly all the time. It can never be violated. So if the officer tells you that you are in violation of the law when he stops you, tell him which one of the three laws you're talking about. Okay, he should tell you which one. Is it the first law, the second law, or the third law, okay? So you have to be, because that's the only three laws, and you cannot violate them. So he's lying. So the officer is lying to you. Please do not tell them my name when you are in court, okay? Because don't drag me into your, because I cannot help you with that. No, Oscar, they cannot. Oscar is asking about black holes. Can they defy laws? Absolutely not, okay? Everything obeys the laws. I mean, you're asking a question a little bit outside of this thing in here, in the sense that these laws are what is known as classical physics. There will be places where we see that we need to repeat. As a matter of fact, part of the consequence of the law is if it is violated, then we have to abandon it at once. It will no longer be valid. If 1,000,000 times you do an experiment, and 1,000,000 times the law is complied with, and in one experiment, only one in 1,000,000, the law is violated, at that point it has to be abandoned at once. Okay, the law has to be abandoned at once. Okay, so it has to be true all the time, and that is actually what's happening in this situation in here. So we had to come up with better laws, and we'll talk about that when time comes for it. But for everyday mundane applications, these three laws are all there is, all you need, okay? So the first law is, and I'm going to do a demo for you guys. So I'm going to switch cameras, okay? So let me go into, where is my, first of all, I need to stop sharing. And I need to go to the camera and switch camera. Does everybody look at this camera that shows something from AAA, which I have no idea what it is, okay?
Yes.
Okay, so what I have in here, I have a nickel, okay? And I'm going to do the experiment suggested in the book. So I'm going to do, kick it in here, okay? What happened is this paper will fly on the other side. And because of the first law, this one resists the change in motion and will stay in place. This, you have seen it probably with, at least on YouTube, maybe where the waiter pulls the the plastic under the dishes, and the dishes stay in place and everything else. So I'm going to do this. Oops, nothing happened because I kicked it actually from the bottom. And it flew to the other end, okay? Does everybody see that? Did everybody see that? Oh, did I miss? Excuse me, let me grab my paper, okay? It flew all the way to the other side, okay? So basically what happened in here was when I kicked the paper, its motion, state of motion changed. Yes, it was sitting still. Now it has moved, okay? When I gave it this force, actually, this is a push, okay? This one has a mass, has inertia. It did not like that change. So it stayed in its place, okay? So again, so the nickel stays in its place. Here is item, what are we at? Item 3 of the discussion. You are supposed to do this at home. And you are supposed to show us a picture of your setting and tell us that it worked or it did not work. You're supposed to take a cup, get a nickel or a dime or a quarter. Try to get either a nickel or a quarter because they're a little bit heavier. They have more inertia, okay? And try to do this experiment at home, okay? And you're going to take a picture to the best of your abilities and do the demo. Now, here is another setting of the same demo where the inertia also is demonstrated. So I'm going to do the same thing, okay? Except I'm going to do it slowly, okay? So I'm going to give it slow pull in here. This does not seem to work, does it? When I pull it slowly, okay? But when I give it a kick, in this case, the first law works beautifully. So let me go back. Let me first of all switch cameras again. And let me go back into sharing the screen. And let's put the statement for the first law. So the first law says the following, basically. If an object was at rest, like the nickel was, it wants to stay at rest. Okay? If an object was moving at constant speed, it will continue moving at constant speed in the same direction. Case in point, you're sitting in a car, you have the cruise control on, and then all of a sudden something jumped in front of you and you have to stop. So what you do, you hit the brakes. And if it were not for the seat belt, your body would want to continue in that same direction. So in this case, the car stopped, but you don't want to stop. You're going to move forward. If you're sitting still in the car and waiting in the red light and all of a sudden it goes green and you push the accelerator, or the person who's driving pushes the accelerator very hard, your body also wants to go back in this situation, okay? It wants to keep its state of motion. So in this case, if an object, so this is the item 2 of the discussion, by the way. So we have 3 so far, okay? That you're supposed to summarize them. If an item is at rest, its tendency, no, if an item is at rest, it will stay at rest. And if not, if it's moving, it is moving, it's moving, it is going to keep moving in the same direction with the same speed. When is that? As long as it is under no net forces. So this condition deals with one object and 0 net forces. So that is law number 1 applies. Law number 2. let's jump into, let's talk about law number 2. Law number 2, I still have one object, but I have net forces now. Okay. This law says the following. An object under net forces accelerates in such a way the acceleration A is equal to the force divided by its inertia M. The more mass, the harder for you to accelerate the object or slow down the object. So this is the second law of Newton. The acceleration is proportional to the force, but inversely proportional to the mass. Okay. This is very important because the mass in here plays a major role. I mean, it's very hard to stop a train, for example, if it's moving 5 miles an hour, than to stop, for example, a soccer ball going 5 miles per hour. Okay, it's much easier for me to stop this one than to stop 5 miles per hour is nothing, by the way. Okay, but the train, even at 5 miles per hour, it's very hard to stop it by hand, basically. So you need a lot of brakes to stop it. Okay, so that is, or same thing. It's very hard to accelerate the train going from 0 to 5 miles per hour than it is to just basically push the ball to do the same thing. The mass plays a role. The more mass you have, the harder it is to accelerate. That's what this expression is telling you. This is why I was saying that most physicists start from this equation, because it has numbers in it. The last law that we will know is the third law. Both of these laws dealt with one object. The first one under no net forces, the second one is under net forces. This third law deals with more than one object. If the universe is made up of one object only, then we really don't need the third law. We have the first and the second law, and that's it. The third law says the following: if two objects interact, that's a condition, actually. Even if you have more than two objects and they don't interact, then in this case you can treat them separately, either under the first law or the second law. But if they do interact, they exert same forces in opposite directions. This is called sometimes the law of action and reaction. Here is the deal. I have the wall in here. I have my hand is object 1, the wall is object 2. There is no interaction in this case, so I can treat them with the first or the second law. But if I push on the wall pushes back on me with the same equal force but opposite direction. Okay? If it doesn't do that, my hand will move forward. If I exert more force than the wall, my hand will go inside the wall. If the wall somehow exerts more force than my hand, it's going to basically push against my hand. But the reason why I know they are equal and opposite, because I'm exerting a force and nothing is moving, so the other one must exert an equal force. Which one is the action, which one is the reaction? It's just a matter of what you call in here. Just because of the fact that I decided to push does not make my force an action and the wall's reaction. And from the vantage point of this configuration, either one can be called an action and the other one is a reaction. Okay, so this is some of the terminologies that we have used in here. So I'm hoping you guys will put it in your own words, to look through the notations, because I'm telling you, this is the biggest deal there is. In this class, we're going to refer to these two things, these three things a lot. Most of the times when we're doing calculations and stuff like that, we will deal with the second law. So I want to really emphasize on this point so that you guys understand. I still did not answer the second question. The reason why, first of all, that's all you need is the following situation. If there are no net forces and you have a single object, you have solved your problem. You can use just the first law. Now, if you still have only one object, but somehow that object is under some net forces, people are pushing and pulling on it, then in this case, you really need the second law to handle it. Now, if you happen to have more than a single object in the universe, and the universe has more than a single object, then in this situation, depending on the situation, do these objects interact or not? If they don't interact, then I have to fall back either on the first law or the second law. Now, if they do interact, then I have to invoke the third law. That's all I need. There is no other scenario that you can think of, no matter what. It's all you need. It's all you need, absolutely. So that's why the first statement is correct. Now, the second statement is, why do we need to proceed? There are some interesting questions that we're going to answer them down the road, and we will see the relevance of proceeding, okay? Otherwise, you're absolutely right. I mean, we're done. We should be going home. I mean, you have to know how to apply them. That's the only thing. Once we know how to do them, then that's it. We don't need anything else. We really are done, okay? But as I'm saying in here, there will be questions, okay? So you're going to hold me to this statement. Okay, we're in week 3 now. Tell us, why do we need to proceed now? Okay, okay, you gathered us in here and somehow you have this thing in here that you're dangling in there, getting your grades. That's fine. We're going to give you that, but you promised us something in here that we need to proceed. So I'm going to answer that question, okay? Why do we need to proceed? Because I'm really trying to get you intellectually involved with these things, to really be engaged in it so that you understand the relevance of these things and how great minds were thinking. This Mr. Newton was in 1664 or something, just like this time when we are in it right now, just before, actually it was before the plague that hit London at that time in Europe. He was student just like you guys. He was sitting in a university at that time, taking classes when he invented these laws, when he came up with these 3 laws. Okay, so he was not a doctorate or anything like that to do this thing. So he still was a student, and he came up with these 3 laws. First of all, out of fairness, and he also claimed it. He did not really claim it, but he also stated it. The first law is not really his work; it's Galileo's work. The first law is Mr. Galileo, when he was experimenting with the inclined plane and all of that. It is really verbatim from Mr. Galileo's work. But the second law and the third law are what he did, okay? And that's it. That's in his book, Principia of Mechanics, or something like that, Principles of Mechanics, that he published later on. But that's basically the whole thing, okay? So that's really what we have to do, okay? So we need to proceed from this point on. This is what I was talking about. Okay, and this experiment we did, and this is what your item 3 of the discussion you're supposed to do on your own. Well, if it doesn't work, that's fine. Probably it's a good idea just to grab some, what we call them, those cards or something. It has to be a little bit of a heavy stock. Don't pick up a piece of paper from your notebook, because it might not work, okay? Because when you give it a kick, it might crumble and get dragged with it the quarter or the nickel, okay? Try to get something. Is it heavy? Needs to be of a card stock. Needs to be this type, okay? Otherwise, okay? Any postcard will do, okay? Postcard will do, okay? Try to take a picture of it. And if it doesn't work, that's fine. You're not, I'm supposed to be expert on it. Try to perfect it though, so that you're convinced that it's actually the law of inertia at this point at work, okay? This experiment is an interesting one. Please, when you do it, if you try to do it, don't do it with a big massive object, okay? With 1 kilogram would be plenty. Don't go into something that is going to be too heavy, then it might hurt you if it falls. If you drag it slowly, it's going to snap in the top in here. Why is that? Is because you're pulling with a force. In addition to that, there is the weight of the in here that you're pulling. So these 2 forces will combine, and you're giving enough time for this mass to accelerate. until this one gives up, till this one snaps in the air. If you pull it too fast, this too actually is going to snap in here because the mass resistance change in motion. So if we're going to do this one, you have to be careful with it. Same thing with this one, because it might fall on your hand and hurt it. And this is what I was talking about in terms of the inertia. Okay, the car stopped, but you won't. Okay, and this is actually one of the experiment you can do. Actually, this is the same thing, because if you're sitting in the car at that point, you and the car and everything else is traveling with the same speed. So in this case, the experiment of the projectile, the free fall will follow through in here. There is an interesting discussion about this experiment because it's a big deal. It is a very important experiment that really confused people big time during the time of Mr. Galileo. Because if we look at the calculations and you say that the Earth is moving around at this speed, going around the sun, how in the world a bird is going to catch the worm in this case? Because here is the problem. Let's say the bird is sitting on the tree, and the tree is attached to the Earth, and the Earth on it, there is a worm in here, and everybody is moving with this speed. 30 kilometers every second is a very, very fast speed, okay? 1 second. Let's say, for example, the bird takes about 2 seconds to fly in here to the ground to pick up its worm. If the Earth is moving with this speed, after 2 seconds, the worm and the Earth and the tree would have moved 60 kilometers, about 40 miles away from the bird. So by the time the bird reaches the ground, the entire Earth would have moved 40 kilometers away. So that was a problem that Mr. Galileo was facing when he basically looked at the experiments and observations, and the Earth is actually moving around the sun and not the other way around. Actually, it was Copernicus who did that, and Mr. Galileo basically subscribed to that idea. So this is something that needed to be resolved. Do you guys understand the problem or not? How in the world can a bird catch the worm? Let me again describe how it is. At this point, when the bird is sitting on the branch of the tree, there is no problem. The bird is sitting on the tree is attached to the ground, and the worm is on the ground. So everybody is moving around the sun, okay? The minute the bird decides to go and grab the worm, the minute that happens, while the tree, the worm, and the Earth actually move away, and the bird will find itself looking at nothing, moving. The whole thing is moving away from it. How did we resolve this issue? It was the law of inertia. Because of the fact that the bird is actually also attached to the tree at this point, the bird, the tree, and the worm, they're actually all moving in the same direction. So if just the bird flies out of the branch, it's still moving in the same direction with the Earth and everybody else. So that is the law of inertia. So all it has to do is, so while everybody is moving in this direction, so if this guy's move here, and this one moves here, and the Earth actually moved this much, the bird also will move this much and will always seize the worm underneath. So if it flies, it's always flying this way. So the motion in here looks like this, and it's going to catch it in here. So it's going to grab it still. And that is the law of inertia. Because even though the bird is free from the branch, it's still moving with the same thing as everybody else. Okay? We're not talking about the air. We're talking about the inertia only. The air, if you want to cancel the air, and it's still going to be dragged in the same direction. Okay, so that was the answer to the concerns that people raised when Mr. Copernicus made that claim that the Earth actually is moving around the sun with this much speed, which is a lot of speed. It's easy to find, basically. It's not hard to do. The Earth distance to the Earth from the Earth to the sun, so this is the sun, this is the Earth, is 150 million kilometers on average. And the circumference is 2 pi times this number. So that's the distance the Earth travels in a year. So on August 23rd, 2022, we would have traveled this distance. We would have gone the whole thing. Okay? And that is basically the point where we started from. That's a circumference. And that takes us 1 year to do that. So we can find the speed with which we are moving. It turns out to be about 30 kilometers per second. A lot of speed. A lot of speed. That means we started around 11:10. It's almost an hour. We have traveled 3,600 times 30 kilometers. Traveled a long way in 1 hour. Okay, we were way back. Actually, you cannot even see where we were right now. We were about 20,000 kilometers away when we started the class, and we moved all the way to here. Okay, and we're not stopping. Actually, we're continuing to move. And this is how to answer that question. It's from the second law of thermodynamics, second law of Newton. Okay, so it's amazing. We can understand this problem now. This problem is solved. So the people who were questioning these things, they really have no legitimacy for it. This is an experiment for the second law. The more mass, the harder it is to move. And this is the free fall. All objects fall with the same force of gravity, G. This is not in lieu of you guys reading the material. So I'm just going through it right now. Okay. And that's the drag force. So I'm going to conclude this discussion by having the following points again, which are the summary from the beginning in here. And that is actually the first slide. These are the 3 laws of Newton. Okay, you're supposed to read the book. And that is item 2 of the discussion today, where you're going to put them in your own words. And because this is the biggest, probably most important day in your life, in at least learning physical science, I'm asking that you post them in there. You write them in your own words. They don't necessarily have to be in this condition. As long as the first condition is one object, no net forces, then if an object was at rest, it's going to stay at rest. If it was moving, it's going to continue moving in the same direction with the same speed. Okay? If an object is under net forces, in this case, an object will experience an acceleration, change in motion, and that acceleration is proportional to the force and inversely proportional to the mass. Usually, conveniently, we write this expression as acceleration A is equal to force over mass. Okay? Most of the literature, though, you will find it written as F equals to ma. So if somebody asks you, what did you learn from this class at all? It's F equals to ma. Okay? The force equals to mass times acceleration. That is by far the most important thing you're going to learn in this classroom. Okay? And then, if there are more than a single object, and if these 2 objects interact, they do so in such a way, if one exerts a force on the other exerts a force that is equal in magnitude, but opposite in direction. Action, reaction. Okay? So, this is in a nutshell the stuff that we're supposed to have covered in here for the discussions, for the materials in here. Let me go back and to make sure that I have all of my notes covered. Yeah, about that, about this. So here is the problem. So you're supposed to do your reading in this sections in here. So let me stop sharing the screen and come back into this screen. Share. Again, you are supposed to do yeah, you're supposed to look at this. You're going to go through the materials, the reading required materials, okay? And go through the examples. You're supposed to do a demo, actually, part of your discussion items in here, okay? The thing with it is, I'm hoping that you guys enjoy yourselves while doing that. This is not like looking at it as a chore. It's supposed to be something that you have fun with, okay? Because I do. I'm hoping that you do the same thing too, okay? and understand this material is in here. There will be in the future other assignments that include of the type calculations, similar to what was done in here, where as an item of the discussion again, that you're supposed to be working in teams and working on these things. Any questions so far?
No.
Okay, very good. So again, it is very, very important that you complete the assignment. That's what I would start with. If I didn't do it already, that's what I would do right away, okay? That's what is right now, what I have to do. I know I only have, let me see. I have quite a few people who did not submit this one. So it's still a lot of you who did not submit it. So I really need to make sure that everybody is submitting that. And at this point, I saw 1, 2, 3, 4, 5, 6, 7, 8. 8 submissions so far, okay? So I know that there is quite a few people, actually more than 2/3 of the class did not submit their assignment. So this is by far the most important thing that you have to complete by Thursday, the first part, by Saturday, the second part, okay? Because it's going to help you stay in the class. Otherwise, you don't want that, okay? Because it's really, you don't want to be really frustrated with that, okay? So I'm going to post the recording later on Canvas. I'm going to reach out for the people who did not submit that. And if you guys are experiencing any problems or having any issues, please let me know. And that's it. That's for today's stuff in here. Unless you guys have any questions.
So for the discussion, all we need, it's 2, we need a, the first question is how we handle problems. And then for the second one, we need to state the laws.
And there was a third one. Anybody else?
The experiment, the third one?
Yes, the demo.
Oh, okay.
Okay, either you take a picture of your setting so that you're doing that.
For the experiment, we need to take a picture, like of us doing it,
Yeah, a picture of your setup.
of
Okay.
our setup. Oh, okay.
Yeah, a picture of your setup, and that would be enough. Okay. Picture of everything to make sure that you're enjoying yourself. Okay. I want to make sure that you're happy, because that's what makes me happy. I don't know what you guys do, but I'm hoping that you will be infected with the same disease I have. Okay. That is to have fun with physics. Okay. Okay, I will stop the recording.